In this video, we'll talk about compound inequalities, in particular how to solve them and how to plot the solutions on number lines. So let's go ahead and take a look at an example of something that may be kind of already like a solved compound inequality. What makes it a compound inequality is it has the word and or in there. We're really talking about two different possible sets of numbers, or even one number set that has a couple of stipulations on it. So what we're looking at here is we're saying, okay, x is less than or equal to 12 and x is greater than 3. If we were asked to plot this on a number line, and again we have to kind of think about what numbers work here. So we've got 12, we've got 3, those are points of interest, and I'm just going to put 0 in here for perspective. So x is less than or equal to 12. If we were to plot this individually, we'd have our mark at 12, it'd be a solid dot, and it's less than, so it's going to go to the left. Likewise, for this x is greater than 3, we'd have our number line, we'd have a 3, we'd have an open dot because it can't be equal to, and it would be going to the right. Now what we're looking for here, the and, we're looking at what do these two sets have in common? What common ground do they share? And it would seem to me that they have everything between 3 and 12, where 3 would be an open dot and 12 would be filled in. These are the only values that they have in common here. And if I think about numbers that fit this or these two stipulations with the and, if I pick a number such as 10, 10 works. If I pick -2, that doesn't fit the second confine here. It's got to be greater than 3. If I pick 24, sure, it's greater than 3, but it's not less than or equal to 12. So this would be a plot for this compound inequality. So let's take a look at a different case here. Let's look at the or possibility. Remember, or in mathematics is the inclusive or. So it does allow for the possibility of both, where there is overlap. So again, if I'm looking at x is less than -7, I know that if I have 0 here and then I have -7 there, we're going to have an open dot. It's -7 and it's going to go to the left. That's how I would plot that one individually. I can also look at x minus 3, or x is greater than 3. And again, I'd have a 0. I'd have a mark at 3. That would be an open dot, and it's going to be greater, so it's going to go to the right. Now, or, I am essentially combining both of these number sets. I'm saying it could be in either one of these. So I'm basically taking these two solution sets and I'm putting them together. Any one of these would work, so I'm going to kind of put them all in one giant solution set. So if I have one number line, all right, I've got a mark at -7, I've got a mark at 3. Both have open dots, one pointing to the right, one pointing to the left. Any number would work here. And again, it boils down to this or possibility. There's no overlap in this case, so I don't have to worry about the inclusive versus exclusive or. I can have numbers that are less than -7, and it's also possible that I could choose numbers that are greater than 3. All it matters is that I have the capability of picking one. All I have to do is satisfy one condition here because of the or. So in this case, any number that's less than -7 and any number greater than 3 would work in my solution set. So if I pick, for instance, 5, that would be fine. If I pick -12, that's also fine. However, if I pick 2, that's not going to work. So let's walk through an example where we actually solve one of these things. So sometimes you're not going to be given something as clear-cut as x is greater than this number and x is less than or equal to this number. Sometimes you'll be given two possible inequalities and we'll have to solve them both out individually. So solving a compound inequality, what I like to do is I like to just treat them individually first, and then I'll worry about what happens at the end. The or just kind of carries along. So I'm going to go ahead and solve this. I'm going to subtract 9 from both sides, which I can do. That's not going to mess with the inequality. And then I'm going to divide by a +2, which again I can do that without having to flip. So I get that x is greater than -3, or, and this is where I do the other side, I can write this as -4 is greater than 15 by subtracting 5 from both sides. Oh, negative 4x, forgive me there. And then I'm going to divide by a negative. Now, keep in mind when I divide by a negative, I have to flip the inequality. So x is going to be less than negative 15/4. So I have to consider a number line that allows for this. So if I was to plot this, let's say there's 0, negative 3 would be here, and negative 15/4 would be somewhere just before that. So x is less than, or is greater than negative 3, which could be a hollow dot there. Now what's going to happen here is kind of weird, but it's going to work out that anything would work because there's that much overlap. So in this case, we could actually say there's an infinite number of solutions. Or we could say all possible solutions. But I can take that same idea and it's going to boil down to something like this where I have, just like before, x is greater than a number, x is less than a number, the less than or equal to is the greater than or equal to is, and then the and or are going to dictate kind of how I draw my solution set. If I'm looking at and, I'm looking at what the two sets have in common and only what they have in common. With or, it can satisfy one, all, or none. Or one, all, and that would be all I would need. If it doesn't satisfy anything, then there'd be no solution. So say this was an and case here. Well, I guess if it was an and case, in this case, it would just be the in-between what those two have. If it was a little bit flipped, say x is less than negative 3 and x is greater than 2, well, there is no one number that can satisfy both of those conditions. So it is possible to have no solutions here. So compound inequalities, solve them both individually, and then afterwards kind of plot, using what we know about and or, a number line.